The objective of this video, we will show that triangles are similar by angle-angle-similarity. And you can abbreviate that with AA and the similarity symbol. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So in my figure here, I'm given that angle K is congruent to angle Y, and angle J is congruent to angle X. So because I have two sets of angles that are congruent, I know that triangle JKL is similar to triangle XYZ by angle-angle-similarity. So I don't have to show all three angles are congruent, because by the third angle theorem, once I have two congruent angles, I know the third angle is congruent, and so that would be redundant to go to that trouble. So we only have to show two angles congruent. And then I know that the triangles are similar. So for example 1, we're going to look at these two triangles, ABC and DEF, and we're going to determine whether or not they're similar, and if they are, write a similarity statement. So if I look at the figure, I can see in triangle DEF, they've only given me the right angle and 22 degrees, and so I can figure out that angle F is 68 degrees. And once I've done that, I can see that I have two sets of congruent angles. So I've got angle C is congruent to angle F, because they're both 68 degrees, and angle B is congruent to angle E, because all right angles are congruent. And so now I'm going to write a similarity statement. I know that triangle ABC is similar to triangle DEF by angle-angle-similarity. So again, when they ask for a similarity statement, they're asking for that statement right there. Okay, so here are two examples for you to try on your own. Are the triangles similar? And if they are, write a similarity statement for them. So first, take a look at example A, see what you think, pause the video, and figure it out for yourself. Okay, so I found the missing angle. Angle Q here is 31, and angle G is also 31 degrees. And then I can see that I have two additional angles that have the same measure. R and F are both 78 degrees. So since I have two sets of congruent angles, I know that triangle PQR is similar to triangle HGF. All right, now take a look at example B and decide whether those are similar to each other. Pause the video now. All right, so I found angle Q was 100 degrees and angle F was 43 degrees. So the result was I only had one pair of congruent angles, and that's not enough to say that the triangles are similar. So the answer to that one is no, the triangles are not similar. All right, so in example 2, we're going to show that I have two triangles that are similar. So I'm looking at triangle RTV. And I'm looking at triangle RQS. Okay, so they gave me enough information in the figure to say that angle RTV is congruent to angle RQS, because they both measure 49 degrees. And then I see that I have an overlapping angle. I can see that angle R is congruent to itself by the reflexive property. And therefore, since I have two pairs of congruent angles, I know that triangle RTV is similar to triangle RQS by angle-angle-similarity. So now it's your turn to do one. I want you to take the time to figure out how you could show that triangle BCD is similar to triangle EFD. Go ahead and write down your answer after you pause the video now. So we see that angle C is congruent to angle F because all right angles are congruent. And angle BDC is congruent to angle EDF because vertical angles are congruent. Therefore, angle BCD is similar to triangle BCD is similar to triangle EFD by angle-angle-similarity. Example 3, we are going to prove triangles are similar. We're given the figure at the right, and we're going to prove that triangle LMN is similar to triangle NOP. So in the figure, I can see that angle L is congruent to angle ONP. And then I also have parallel lines marked. MN is parallel to OP. So whenever I have parallel lines, I should be asking myself, okay, there's going to be some congruent angles here. In this case, the angles that I'm interested in are right here, my corresponding angles. So angle MNL is congruent to angle P by the corresponding angles postulate. And therefore, I know that triangle LMN is similar to NOP because of angle-angle-similarity. All right, looking at example 4, I can use similar triangles to solve real-life problems. In this case, we've got a lifeguard standing beside a lifeguard chair on the beach. So here's my chair on the beach, and here's my lifeguard. And the lifeguard is 6'4" tall. And he's casting a shadow that is 48 inches long. And the chair is casting a shadow that is 6 feet long. How tall is the chair? So if the sun is shining down, it's going to be shining at the same angle on both of them. So the angle between the sunlight and the ground is going to be congruent. And they're both standing straight up, so they're both making right angles. So I have two similar triangles. So that means that my sides are going to be proportional. And so x over 6'4" is going to have to equal 6 feet over 48 inches. Well, all my units are mixed up here, so I need to convert them. And it's going to be easiest to convert everything to inches. So my x stays the same. 6'4" is 76 inches, and 6 feet is 72 inches, and then we already have our 48 inches. Now before I cross multiply, I notice that I can reduce the fraction on the right. 24 goes into both of those numbers, goes into 72 3 times, and into 48 2 times. And now if I cross multiply, I get that 2x is equal to 3 times 76, or 228. And so when I divide by 2, I get that x is equal to 114 inches. And we'll go ahead and convert that back to feet and inches. That comes out to 9 feet, 6 inches. So the chair is 9 feet, 6 inches tall. And that concludes the video. Thank you for watching.